Variable acceleration is trying to find the different speeds of a particle or body. The displacement of a body or particle at time equals t is s. This represents displacement. The next would be v, which is velocity, and the last acceleration. To get from displacement to velocity, you differentiate ds by dt, and to get from velocity to acceleration, you differentiate velocity by the time. To get from acceleration to velocity, you integrate acceleration, and to get from velocity to displacement, you integrate velocity. Now I'm going to show you a variable acceleration question example. A particle moves at an acceleration of 2t minus 4, where t represents time. When time equals 0, velocity equals 3 and displacement equals 2. So part A is finding an expression in terms of t for velocity. Velocity equals ds over dt, which you can get from acceleration by integrating acceleration. So integrate acceleration, which is 2t minus 4, and you will get t squared minus 4t plus c. Now to find c, you have to put t equals 0 and v equals 3. So 3 equals 0 squared minus 4, and you will get c equals 3. So the expression for velocity would be t squared minus 4t plus 3. Okay, the second part of the question is to find an expression for displacement, which is the same as integrating velocity. So when you integrate velocity, you would get t cubed over 3 minus squared plus 3t plus c. The same thing here. You have to try and find c. And when t equals 0, displacement equals 2. So 2 would be equals to 0 cubed over 3 minus 2, 0 squared. And c would equals 2. So the expression for displacement would be t cubed over 3 minus 2t squared plus 3t plus 2. Part 3 of the question is finding the displacement when the particle is at rest. When the particle is at rest, the velocity equals 0. So take the equation you have of velocity, which equals t squared minus 4t plus 3, and equals that to 0. When you factorize this equation, you would get t minus 1 times t minus 3 equals 0. So t would equals 1 and t would equal 0. So this means the particle is at rest at times 1 and times 3. Okay, so if this is your axis and this is your curve, you will be given 2 points A and B with a shaded area. Now volume of revolution is about finding the area when you take this shaded area and rotate it 360 degrees around the x-axis so that you get a solid. And volume of revolution is the volume of this whole solid. Now to find this volume, you use the equation V equals pi integrate b a y squared dx, y being the equation of this curve. So now you're trying to find the area between two curves, which will be the shaded area. First, you have to find places where the two curves intersect and call them A and P. After you have this limit, you can now figure out the area of the shaded part using integration, which would be integrate gx minus integrate of fx, which equals integration gx minus fx. Why this happens is because from that curve, if you take gx, you're taking this part, minusing away fx, which is this part, which will leave you this part. That's why it's a minus. So yeah. Now I'll show you an example so that will be easier to understand. Okay, so they said find the area between two curves, and they give you the equations y equals x squared plus 16 and y equals x 12 minus x. First you have to find the points of intersection. So you make these two equations equal each other. And then you times out this bracket and move them all to one side, which would give you 2x squared minus 12x plus 16 equals 0. Then you divide everything by 2 by simplifying it, so you get x squared minus 6x plus 8 equals 0. And then you factorize this, which would give you x minus 4, x minus 2 equals 0. So x equals 4 and x equals 2. It's easy. Whenever you do this kind of finding area between two curves, you have to like draw the graph out. So you can draw this graph out and it would look like this, because when you time this out, it would be 32, and when you times this out, y value would be 20. So d would be 432, whereas here would be 220. Okay, so then you're using that equation, integration gx minus fx, where gx is the curve on top. You can integrate everything. So then integrate. So area equals integrate 4 upper limit and 2 lower limit. And then you use x squared plus 16. No. The bottom one is x 12 minus x squared plus 16 times out the bracket and simplify everything. You would get 12x minus 16 minus 2x squared dx. When you integrate that, you would get 6x squared minus 16x 2x cubed over 3 4 2. And then you put 4 into all x's minus 2 into all x's, which would give you 6 4 squared minus 16 4 minus 2 4 cubed over 3 minus this whole thing minus 6 2 squared minus 16 2 minus 2 cubed, which would give you 96 minus 64 minus 128 over 3 minus 24 minus 32 minus 16 over 3, which equals minus 32 over 3 minus 40 over 3 equals 8 over 3. You can use your calculator and you will get the same answer, which is equals to 2, 2 over 3. Yay! Okay, so to summarize everything, you need to know the main formula for integration, which is integrate ax to the power of n dx equals ax to the power of n plus 1 over n plus 1. This happens when n does not equals 1. Okay. Another thing you have to do is to get from displacement to velocity, which is displacement over dt, and to acceleration, which is dv over dt. And then you have to use integration to solve problems with area and volume. To find the area enclosed by curve, A equals upper limit, lower limit. The equation integrated. To find the area between two curves, you use the same thing, except this one minus gx, and integrate the whole thing using upper limits. Dx goes there. And finally, to find the volume of revolution, it would equals to pi upper limit, lower limit, equation squared dx. Ta-da! You now know everything. Creepy smiley face guy.